Hi, my name is Wani. Today I'm going to present my practical assignment, which is Smart Greenhouse Monitoring System. This is all for the table of contents that I will present today, which is project overview, problems, purpose, operation, and result. First of all is my project overview. Smart greenhouse monitoring system employ IoT technology to automate and optimize greenhouse environments, fostering sustainable agriculture and driving innovation. These systems aim to optimize growing conditions and minimize waste, significantly enhancing agricultural sustainability. Secondly, is the problem that I want to solve with this smart greenhouse monitoring system. First is monitoring limitation. Traditional greenhouse management lack real-time monitoring, leading to inefficiencies in resource usage and inconsistent environmental conditions. Without continuous monitoring, growers struggle to optimize factors like temperature and soil moisture, resulting in reduced and increased resource of consumption. Secondly is security issues. Traditional greenhouse management often overlooks security, leaving facilities to thief, vandalism, and unauthorized access. This is not only risk financial losses, but also compromise plant health and the safety of personnel. Implementing smart greenhouse monitoring system addresses these challenges by providing real-time monitoring and enhancing security measures. And the purpose of creating this smart greenhouse monitoring system is to optimize greenhouse resource usage. Secondly, is to ensure consistent environmental conditions and enhance greenhouse security. For the implementation, I got watering system, temperature control, movement alarm, and RFID access control. For watering system, I use DHT11 sensor for real-time humidity check. And for demonstration purpose, I have one potentiometer for adjusting humidity data manually for what trigger the watering features. And LED light indicates watering system activation. In this case, I use the yellow LED for the activation status of watering system. Next is temperature control. In this case, the HT11 sensor for real-time temperature check. Also, potentiometer for adjusting humidity data manually. In this case, servo motor move to show the temperature. When the temperature is lower than the threshold, the servo motor will turn left. If the temperature is too high and the servo motor will turn right, indicates that the air fan has been activated. When the temperature is within the optimal range, then both heater and air fan will be turned off, so servo motor returns to 90 degree. Next, I have implemented PRS sensor for the movement detection. PRS sensor will detect the movement that approach them, and it will turn on the buzzer when it detected a motion. Last is RFID access control. RFID reader for authorized access. And in this case, a green LED light will turn on for the granted access and nothing happen for the denied access. And this one is my implementation for the whole system. I will explain further in the next in the demonstration later. So you can see here it have two potentiometer, one they have DHT11 sensor, one servo motor, a RFID reader, a buzzer, and a PIR sensor. And now it's connected to my Raspberry Pi, and I will show to you later. Okay, I will explain my Arduino code now. So in my project, I use DHT library, servo library, and the RFID MFRC522 library. So this is my pin number for all of the equipment I use in this project, which is the PIR sensor, a buzzer, DHT11 sensor, a yellow LED, a green LED, and two potentiometer and one servo. So initialize my DH here I initialize my DHT sensor, declare my servo motor, and this is the pin I use for the reset and the SS pin for my RFID. Now this one is the authorized card UID that I use to grant the RFID access in this project. So this is the initialize the serial communication. I attach my servo motor here. So this one is to set the pin modes, the PIR sensor as input and buzzer, yellow LED, and green LED as output. I start all the equipment here. So this is my loop. So at first, this is to initialize the RFID pre-detected. This one is the function to scan the RFID and check is that the UID for the card is matched with the one I declared before. If yes, then the green LED will turn on for 3 seconds and turn off. If no, then the LED light will not turn on. For this one is the serial I will send to the data to the Raspberry Pi later. So this one, when the access is granted, then RFID detected will return 1. If the access is denied, the RFID detected will return 2. So next will be my motion detection. If the PIR sensor detect any movement and the PIR detected will return 1, at the same time, it will activate the buzzer for 1 second and turn off the buzzer. If there is no motion detected and the PIR detected will return 0. And this one is for reading the real-time temperature and humidity. Because usually our room temperature and humidity is almost same for every day. So I decide to use 2 potentiometer to manually adjust the humidity and temperature. So I got manual humidity there, which I use the map function to restrict the value to 0 until 100 only. It's same goes to the manual temperature also. So if the DHT sensor not working, the serial will return fail to read from DHT sensor. If the DHT sensor can read the data, so it will return all the necessary data here. This one is to print the RFID detection status. And if the real-time humidity or manual humidity that controlled by my potentiometer is lower than 40, then it will turn my yellow LED on. So means that it will trigger the watering system. It also will send the serial as watering status return 1. For this one is the function to control air fan and heater based on the temperature. So I don't really have an air fan and the heater for my prototype, so I just use the servo motor to indicate the air fan and heater. In this case, if in this case, servo motor turn left will be turn on the air fan and turn right will be turn on the heater. And it will turn to middle if both of the heater and air fan turn off. So this one will check the temperature and decide the servo motor to turn left or right or middle. And this one is the receiving the serial from flash later, and it will manually trigger my actuator such as the LED and the servo motor according to the command later. So I indicate some delay here, and this is the function to rotate the servo, and it will write the angle according to the temperature. This one is to compare the UID according to the scan UID with the UID I set inside my code just now. So this one is the prototype I done for this smart greenhouse monitoring system. So I know the wiring is quite messy because yeah, I have 4 features and the wire is here and there, but it's okay, I will explain to you later. So first I want to talk about this. This is the DHT and DHT11 sensor, which will read the real-time humidity and temperature data. And first I will talk about the humidity control. As I mentioned before, this DHT11 is to read the real-time humidity and temperature, but I also have one potentiometer, so I can adjust the humidity manually to demo the watering system. So now this one is the yellow LED is to indicate the watering system is turning on or off. Now the LED light didn't turn on, so means that the humidity is higher than the threshold. So let me adjust the potentiometer, and when the humidity is lower than the threshold, so the yellow LED will turn on, indicates the watering system has been turning on. So the watering system will turning on until the humidity is higher than the threshold I set before. So as you heard that the sound is from the buzzer, which is a movement detect alarm. So when got the movement approach the PIR sensor, and the buzzer will and this buzzer will sounds indicate there is something approach it. It's a bit delay here. Yeah. Okay, then I will talk about the temperature control. For temperature control, I also have a potential meter, so to manually adjust the temperature. So this one, the servo motor is in such serve as the indicator for both heater and air fan. If the servo motor turn left, means that the heater will be turned on, and if the servo motor turn right, means that the air fan will be activated. So if it turn to middle, means that the temperature is within the threshold, so both air fan and heater will be turned off. So now let's adjust the temperature. Yeah, so you can see it's moving here. So let's adjust again. Yeah, so okay, I will show you the data read from the Arduino to you guys later. So now I will introduce you for my RFID reader. So this one is the one that I already insert the UID code inside my code. So now I scan here. So as you can see here, the green LED light turns on for 3 seconds, means that the access granted. So if you can see, I use another card to scan. So the green LED will not turn on, means that the access has been denied. So that's all from my Arduino presentation. I will explain further in the next part. So the next thing is I will explain my read serial code. I have two Python code, which is read serial code, and the Flask code, which name dashboard py here. So at first I will connect to my Arduino here, and this is my database, which name greenhouse. So inside my database there is 1, 2, 3, 4, 5, 6, 7 table. First is the access log for the RFID control. Secondly is the alarm log for the buzzer and movement detect alarm. The third one is the sharing table for heater and airframe, and the fourth one is humidity data. Next is temperature data, user table, which store the admin data for the monitoring system. This one I will introduce further inside my dashboard explanation later. So the last one is the watering log. So get back to my code now. So at first I will fetch my latest data from all of my table inside my greenhouse database. And this is the code, the function to insert the new data inside the database when the read serial code run and read the serial from the Arduino just now. And if everything okay, then this one is the function to extract the sensor data from the Arduino. So if the motion sensor detected yes, and it will insert into the alarm log. So if the RFID detected returns 1, and the access value will be granted, and the data will be inserted into the access log. So this one is to check the real-time humidity or manual humidity. If the humidity is lower than 40, it will activating the watering system. So the watering status inside the watering log here will be, for example, for this one the value here will be activation status here will be on. So same as the watering system for the temperature control. If the temperature is lower than 20, and the heater status here will be turned on, and the airframe status will turn off. So let's look at the heater airframe log. So this one is the data I tested for my read serial code before. So this one on off on off. So if the temperature is higher than 50, so means that the heater need to turn off and airframe need to turn on. So the status will change to on here. And if the temperature is within the threshold, which is an optimal range, so both heater and airframe will be turned off. So yeah, that's all from my read serial code. So now I have changing the delay to control the data reading frequency to 5, so that I can show you guys how the data changing from reading from my Arduino. For example, for this watering log, the data will keep updating the current time here. So when I automatically turn the humidity here, you can see the LED light will turn on, and so that here the status, the activation status for the watering lock will be changed to on also. When I turn it off, when I turn it off, and the activation status here will be off also. So now let us look at the alarm lock. So the alarm lock will only insert the data while the PIR sensor detecting the movement. So the movement detection here will be yes. So now we go to the RFID. So if the RFID is granted here, the LED light will be turned on for 3 seconds and the data will be changed to granted. While introduce my dashboard to you guys. So this one is the dashboard. So I will log out here. So this one is the login registration. I will log in, use my current account inside the table. So let me insert it. So, and after you log in, it will bring you go inside the dashboard. So this is your username, and this is the admin card, a temperature card which show the latest real-time temperature, and a humidity card that shows the manual, the real-time humidity. And this is the watering system turning off and on button. So currently the watering system is off, and the air fan is off, and while the heater is on. So I will explain to you when I click to turn watering system on. The button here will turning on, and the LED light will turning on also. When I turn on for the air fan here, the servo motor will moving, so indicates the air fan has been turning on. So if I turn on the heater, the air fan will turn off and the servo motor will move again. So the next part will be the temperature one. So this one will show the latest 3 patch for the manual temperature and the real-time temperature. So I also have a data visualization to show the average for every 30 minutes for latest 24 hours, the average manual temperature and average real-time temperature. For the table here, it indicates the median, minimum, and maximum for the manual temperature and real-time temperature. For latest 24 hours, you can see the median for the manual temperature is 100, while mean is 0.0 and maximum is 99. So the median for real-time temperature is 29.80, while the real minimum, the mean is 23, and the maximum is 29.000. It have a same design for the humidity part. It also show the manual humidity and real-time humidity for the latest 3 pages for the data here. So it also have the data here, the median, the minimum, maximum, median for real-time humidity and manual humidity. So this one is the latest 3 pages data for the activation status of watering system is off. So this one, if the watering system has turned off, so the red bar will be you can see the red bar here means that the watering system is turned off. If the watering system is turned on, so it will indicate the blue here. For the airfan system also, you can see the data visualization here. The blue bar indicates the airfan status is 1 if the yellow bar indicates the heater status is 1. So after that is the alarm. This will show the latest 3 pages for the motion detected. And this one is the time, the latest time and for chart the motion detected. And this one is the access for the RFID control. So this one is the chart. If the pink color will be the access granted, and if brown color will be access denied. So this one will be the admin list for this greenhouse monitoring system. Currently, there is only one admin account, so only one here. So I will show you for my last code. So this one is the command that to send back the command to the Arduino to manually trigger the LED light and servo motor when I click on or off to the button in my dashboard there. So this one is to check if the device and the action are valid. So it will update the database table also at the same time. So this one is the registration with the validation also. After that, the data will insert into the user table. So this one is the login. The name and user ID will be stored inside the session when you successfully log in through your email. And the name will be displayed here. And this one is to display the admin list. And this one is to display the temperature data table. And this one is to calculate the average for the manual temperature for latest 24 hours with a granularity of 30 minutes. Also with a timestamp for the calculation for the mean, maximum, and median. And the same thing goes to the humidity here. And this is the watering system. It display the data, the latest 3 pages data that inside the watering log table. So this one is also the chart. And that's all for my explanation.